Okay, sorry, I'm going to try to keep this as steady as possible because I have to use my cell phone to record the homework this week. Okay, so list the factors of 40 and 16. Circle the prime factors for each number. So 1, 2, 4, 5, 8, 10, 20, 40 are my factors. My prime numbers, remember 1 is neither prime nor composite. So it will be just 2 and 5 in the front row. 16 would be 1, 2, 4, 8, 16. 2 is my only prime factor, and their common factors would be 1, 2, 4, and 8. All right, number 2, compare using greater than, less than, or equal to. Hopefully you have no questions about that. Looking at B, why is 31 hundredths greater than 305 thousandths? That's because of the 1 in the hundredths place and a 0 in the hundredths place in the other number. Okay, E, I annexed a 0 just to prove that those two were equal. It doesn't change the value. On the complete comparison, you can put in any number as long as it is less than 35 and 56 hundredths and less than 17 and 4 tenths. Okay, looking at number 3, this is an order of operations. Notice that with my groupings, I get 78. Without any groupings, I get 82. Are the answers the same? No, although I have the same factors, my groupings change the product, the end answer, I should say. All right, looking at number 4. Number 4 can be just a little bit confusing because you really have to understand what race times mean. So if in a race, you really want to know whether or not someone came in the fastest, then you are looking for the least time, so the smallest time. So the person that runs the fastest actually has the least time. So this is really asking you to list that person's name from their least time to the greatest time. But before we do that, we're going to round to the nearest tenth. So 61 and 56 hundredths pushes up to 61 and 6 tenths. 62 and 34 hundredths pushes down to 62 and 3 tenths. 60 and 27 hundredths pushes up to 60 and 3 tenths. And 61 and 40 hundredths stays the same, 61 and 4 tenths. Okay, so looking at that, who has the fastest time? Well, if I'm looking, the first numbers are all the same, but the second one, the least time, would be a 0. That's the smallest number, and that would be Kate. So I'm just going to write Kate's name up to the top because she was the fastest. If you numbered it from 3, 4 like this, that's fine as well. Let's see. For the next time, it would be, we're looking again, I see the next number up from 0 would be 1. So looking at the ones, I have a 4 here, which is less than that 6. So then Lindsay would be next. And then after Lindsay would be Alicia. And then finally Danelle would be last. She has the greatest time. Week 7, day 2. Estimated product, I'm going to push 496 to 500 because that's a compatible number. I'm going to push 48 to 50. Now I'm going to throw my 3 zeros down to the side and just multiply 5 times 5, which is 25, and that gives me 25,000. All right, for number 2, I'm actually going to solve it using the algorithm, and that gave me 23,808. Is that compatible? Actually, yes. If I look at 23,000 and 25,000, those are pretty close. Remember, I pushed up both numbers. So because I pushed those numbers up, then my product's going to be a little bit more when I estimate. Okay, looking at this pattern here, I have 7,249 divided by 10 to the power of 3. When I'm dividing, my clue is that I'm going to move my decimal this many times, my exponents times. Okay, so down here where I'm actually going to divide, I start my decimal to the right, the furthest right I can go on my number, and I push 3 times. So that gives me an answer of 7 and 249 thousandths. This 10 to the power of 3 is the same as dividing by 1,000. Looking at my pattern, think 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. I would do the exact same with 5 to the power of 1, 2, and 3. Number 4, creating a number line. So what I did was I saw that I had 8, 9, and 10. I just went on and plotted points next to where it made sense. So I split between 8 and 9 and made it 8.5. so that I would be able to easily place these other decimals. I did the same thing with 9 and 10. I made a 9.5 so that I could know where 9 3/10 went, where 8 7/10 went. So to prove that all of these numbers, which would be the closest to 9, that would give me a range from 8.5 to right before 9.5. Okay, so which numbers would round to 9? It would be 8 7/10 and 9 3/10. All right, looking on the back. Week 7, day 3, find the product. So I just used the algorithm. Remember, when I multiply with decimals, I only count my decimal places. I have one decimal place here. I have another decimal place here. I do not stack my decimals when I multiply. I save them until the end. Notice there's no decimals here in my partial products at all. When I got to the end of my answer, I started my decimal at the back. I counted my places that I would need. I had 1 here and 1 here. 1 plus 1 is 2. So I slid over 2 times, and that gave me 20 72/100. Find the product, same digits. The only thing I notice is I have 2 decimal places here and 1 there. So I'm going to get the exact same numbers, which is 2072. But now I have to figure out where my decimal goes. So I start my decimal all the way to the back, slide 1, 2, and 3 this time, and that gives me 2 72/100. Why do I have 3? I have 2 places here, 1 there. 2 plus 1 is 3. Number 3, find the algorithm. That's exactly what I did. I just multiplied using the algorithm, 58,847. All right. What do you know about about multiplication? To determine which is less, well, I know that 72 times 1 gives me at least 74, so that would give me a 1 in the hundredths place when I'm dividing. 95 is less than 98, so I know that that gives me a 1 in the hundredths place. Notice I have 2 other places here, 2 other places here. So that product or that quotient is going to be at least 100 or more. But when I get here and I see a 21, I know that 23 can go into 2 0 times. 23 can go into 21 0 times. So I'm not going to start with my quotient until I get to the tens place. Okay, same thing with D. I won't get to my quotient until I get to the tens place there as well. All right, number 4, I guess this is on day 3, using mental math, notice the product. There was an error here. You can change that if you like. This should not be thousandths here. It should actually be hundredths. Okay, so 58 times 10 is 580. 58 times 100 is 5,800. 58 times 1,000 is 58,000. What happens when I multiply 58 times 1/10? I slide my decimal 1 time, 5 8/10. What happens when I multiply 58 times 100th? I slide my decimal 2 times, and it gives me 58 hundredths. What happens when I slide my decimal here 3 times because I'm multiplying to the thousandths? It gives me 58 thousandths. Week 7, day 4, I'm going to estimate. This pushes up to 10. This pushes up to 100 when I'm rounding to the nearest tens place. And this pushes to 960. That gives me 1,070. Exact sum would be 1,063 and 38 hundredths. I'm not going to go too in-depth into that one. Okay, order of operations, we should know how to do these. If you solved it correctly using your groupings first, then dividing before you subtract, then you will get 48. Okay, number 3, I have a 2 in the ones place, and it's asking me which number is 1/100th of the value of the 2 in the ones place. Well, I know if I move from the ones place back, that number is 1/10 is great. So that's just dividing back 1. That gives me 1/10. So I would need to divide back 2 to get me 100. So 1/100th would be 2 hundredths. So it would be the 2 in the hundredths place. That is 1/100th of the value of the 2 in the ones place. Okay, create any equation. Just make sure when you solve it that it actually does come out to 30. Have a good evening.